Hello math fans. Today we're going to use a third order Taylor polynomial for f of x equals square root of x to estimate the value of square root of 26. Now of course I realize your pocket calculator should have no trouble at all calculating square root of 26. Mostly this is just to illustrate the theory behind how we can use Taylor polynomials to help us estimate the value of certain numbers. Alright, so the idea that we're going to use is that since 26 is pretty close to 25 and square root of 25 is a nice number, it's 5, what we'll do is find a third order Taylor polynomial for f of x equals square root of x centered at 25. Alright, so if you remember, we've got this formula for the third order Taylor polynomial centered at x equals a. It's going to look like this. Alright, so we've used this before. So what we're going to do now is we're going to compute three derivatives of this function. Okay, so we start off with square root of x. We want to think of that as x to the 1/2. First derivative is 1/2 x to the minus 1/2, so we bring the power down, subtract 1 from the power. Okay, one more derivative, so now we'll bring the exponent of negative 1/2 down, and again subtract 1 from the power. This time we'll combine the coefficients into a single coefficient of negative 1/4. Okay, we need one more derivative because we need a third derivative as we're doing this. Okay, so again, we take the power down, the minus 3/2, and then we subtract 1 from the power. And then once again, we'll combine the coefficients into a single coefficient, this time 3/8. Notice that the minus signs cancel. The next thing we want to do is actually plug in the center, that's a equals 25, into the derivatives. Okay, so if we plug in 25 into the original function, then we just get square root of 25, which is 5. Okay. If we now plug in f double prime into the first derivative, so we're going to get 1/2 25 to the minus 1/2. Now, in order to simplify this, first thing we'll do is we'll take that negative power and write it as, put it in the denominator. So instead of 25 to the minus 1/2, we have 25 to the 1/2, but in the denominator. And of course, a 1/2 power is the same thing as a square root, so now we have 2 times 5 down in the denominator, and so that turns into 1/10. What we'll do as we go along is I'll highlight the values of the derivatives that we get. Okay, so here we have the 5, and we've got the 10, and we're going to use those later. Okay, so now let's keep going. So we take the second derivative now and plug in 25, and now in here we have a 25 to the minus 3/2. Again, we'll move that down into the denominator so that we have 25 to the 3/2. And now what we can do is we can think of that 25 to the 3/2 as being 25 to the 1/2 and then that entire thing cubed. That way, the 25 to the 1/2, that's a square root. We can rewrite that as 5. 5 cubed is 125. And so now we get a value for our second derivative. We'll get negative 1 over 500. Okay, now on to the third derivative. We just have one more to do. Now plugging in the 25, we'll get 3/8 times 25 to the negative 5/2. Okay, same trick as before. We move that down into the denominator by taking advantage of the negative exponent. Rewrite it as 25 to the 1/2, and that whole thing raised to the 5th power. And now that turns into 5 to the 5th power. And we still have that 3/8 lurking around. All right, so maybe you don't know 5 to the 5th power off the top of your head, but that's not all that hard to work out. You end up getting 3,125 for 5 to the 5th power. And then if you combine that with the 8, then you get a 25,000 down in the denominator. Okay, so now, since we've got the values of all the derivatives, we can plug everything into our formula for the third order Taylor polynomial, and we're going to get an expression that looks like this. Okay, so we've just substituted 25 in for a, and now we can actually put in the values of the derivatives that we've computed into this expression. Okay, so we have 5 for the value of f of 25. We've got the 1/10 for f prime, the minus 1 over 500 for f double prime, and finally the 3 over 25,000. So you can see how, like, for instance, this got put into here. All right. Things to keep in mind, the factorial is still here. Okay, so now we're going to try to simplify this expression. So actually what we want to do is we're going to approximate square root of 26. So we'll plug in 26 into this expression and then we'll simplify. Okay, so square root of 26 is approximately equal to the third order Taylor polynomial at 26. We don't know how good an approximation it is, but we'll find out in a minute. It's actually going to be pretty solid. Okay, so we plug in 25 into this expression, and now all we need to do is try to simplify this. So if you look at this, there's no more variables in here. This whole thing is just a number, so let's try to simplify it. First, I'm going to take this 3 factorial here and try to get rid of that. 3 factorial is just 6. Okay, and now each one of these pieces can be simplified pretty nicely. First of all, we can get rid of all these 26 minus 25, right? Those are all just 1. And then we have other things like this here, 1 over 500 times 1 over 2 factorial, that's just 1 over 1,000. Okay, and then this piece here simplifies pretty nicely too. Okay, so if we work out all of that simplification, we'll get this here. Okay, so for instance, in this piece here, that 3 over 6 cancels to leave you with a 1/2, and then so 1/2 times 1 over 25,000 will give you 1 over 50,000. All right, and if we make a common denominator, in fact, the best common denominator to make is 10,000. That way we can write this as a decimal. Okay, so I'm going to leave you with the details of trying to get this common denominator together. And now if you make that into a single fraction, you'll get something that looks like this. And now that can be very easily made into a decimal. All right, so this is our estimate, our approximation for the value of square root of 26. It comes out to 5.09902. Now, as I said, your pocket calculator will do this very nicely for you. And in fact, if you do that, if you use your pocket calculator to get the value of square root of 26 and look at it to 5 decimal places, you're actually going to get the same thing. So this approximation is really very good. All right, that's all for now.